Yeah, nothing's on yet, Ken.
Okay, let's see if we can get this thing on the road here. Welcome everybody who came. We appreciate you being here. We're going to start off with recognizing visitors. Do we have any visitors? Your name, call sign, and where you from? All right. Awesome. Thank you. Okay. And you? What's your name?
Hartley.
Hartley, and your name? Harper? Awesome. Anybody else out here? And we have a whole bunch of guests right up here. I'll come right back. What's your name, sir?
John Mortensen.
And your call sign?
I don't know.
Okay,
Nathan Farrow, KC5YTH.
welcome,
Amber Pero, Katie 5YQU.
welcome.
Bo Schwabing, don't have a call sign.
Yet. Awesome, thank you. And you, sir, back there. What's your name? Jonathan? Welcome, Jonathan. Thank you for coming.
Although you guys have probably heard me on the air.
Could be.
My
Could be.
experience as a kid growing up.
All right, I don't want to recognize the people on the Zoom. We've got Peter Laws. We got Carl SSW. We got Glenn. Thank you, Glenn, for coming. Ken Sandborg up there in the secret corner there. Mr. Lee Greenleaf, thank you for coming. And last but not least, the great Mr. Al AE5L. Thank you for coming. All right, we're going to start off with our introductions. And we're going to start over here with Mark Klein.
Mark Klein, N5HZR.
Mark Clayton, N5AZQ.
85 Bill, 85 UGO.
Chris,
Chris, K5JZM.
this young lady right here.
Oh, I'm sorry, Debbie.
Debbie. Okay. Oh, awesome. Awesome. Bing's got his mouth full. I'll go to Denny. All right. And then we NI5G Bing. Thank you, Ed. Yeah. Why not? Okay. Mr. Dwayne. Thank you. All right, and Dean just upgraded to extra. Let's give him a hand. All right, yes, sir. Thank you, Mr. Mike. All right, thank you. Mr. Rodney.
Rodney, KF5UZA. Bill, AE5F.
Bill's the donut king right here.
Ken, K8WGE.
Thank you, Ken.
Fred, KC5FPC.
All right,
Galen, WX5ML1.
thank you. Good to see you, Tom. All right. Yes, sir. Thank you, sir. Mr.
Larry, W5LHG. Ken, N5KUK.
All right, and I am Wayne, KK5IO, and we got one guy in the corner. All right, thank you. And I already introduced the guys up on the screen, so we're good to go. This time, I'm just going to turn it over to Mr. Mark Klein for our morning program.
Well, thank you all for coming. I was on Facebook or QRZ or something silly, and popped an ad for something called OK Robotics, and I went, "What a silly name!" Unless you were from Oklahoma, and sure enough, they're from Oklahoma. So I sent them a message, and they said, "Yeah, we're just up the road in South Oklahoma City somewhere." That's kind of cool. These guys build, I'm sure they'll tell you more and better stuff than I will, but they build all kinds of printed circuit boards from the design to the build. And they've got a couple of cool toys that we've been playing with all morning long. So with no further ado, you've already been introduced to Nathan and Amber and the crowd, and I'll let you go, sir. Go ahead.
Well, good morning, everyone. Well, I was asked to get this. Oh.
Whatever you say, it's for fussing.
All right, now we're on record. So anyway, I was asked to get this puppy started. So do we have our slides or?
Yeah.
All right, thank you. Oh, all right, here we go. Anyway, as you guys may remember, I'm Amber Pero, Katie 5YQU. This is my husband, Nathan Perro, KC5YTH. We're the owners of Oklahoma Robotics. And what Oklahoma Robotics does is we do a lot of work with automation for manufacturing and industrial applications, as well as prototype design. Today, we also have Bo Schwabe. He does a lot of our circuit board design and also programming. He's also got all the cool stuff, so you definitely want to talk to him. And then we also have John Mortensen, who is also my dad. He's an electrical engineer, and he has a long career history of automation systems and automation work in the oil field. So today we want to come and share with you a little bit about some of the projects we've done, but not only our projects, but also the process we go through. We started out about 15 years ago. We've been debating the timeline on this as a hobby and as a club. About 10 years ago, it turned into a business when we started getting paid projects. And 3, maybe 4 years ago, my husband quit his day job and took this full time. You'll find us in Southeast Oklahoma City. Just give us a shout. We'd love to have you come by and stop at the shop. And the thing you need to know, it's basically a playground. So be sure to come by and visit us. I did want to go through our process, and it's got really cool takeaways, not only for our commercial industrial side of things, but also if you guys are also working on projects, just some basic engineering process. First, we'll start off with like an evaluation, then a brainstorm, research, design, and the deployment. So to get this started, we're going to talk about evaluation first, and I'm turning this over to Nathan.
Hi, guys. This is Nathan Perro, KC5YTH, and I'm the owner of Oklahoma Robotics, along with Amber. And we want to tell you about the process that we go through when we meet with a new client. So the first thing that we do is we want that client to take us and walk us through their facility. So we go into their facility and we see what they do, what their current processes are. In a manufacturing environment, there's a lot of activities taking place, and there's a lot of different things that go into making a product. And so normally in any manufacturing environment, there's always something that is creating a pain in the process, something difficult, something that's slowing down the process, something that's making it difficult for them to get as much product out the door as they would like. There's also factors like human injuries and different things that people are experiencing difficulty doing something. One of our clients makes pipe, and they have these rubber gaskets that have to be installed inside a groove in the pipe. And on the larger pipes up in the 6 and 8 inch range, that's no big deal for a person to do that, stick their hand in there and put that in the groove. But they also make pipes all the way down into the 2 inch range. And they've had a lot of repetitive motion injuries with people trying to get inside there and put the gasket inside that groove, because it's about 3 inches deep inside the bell of the pipe. So they've contacted us and said, hey, come look at our process and take a look at this and see what we can do to automate this. Well, inserting a flexible round gasket inside a seat, inside a groove, inside a small pipe is no easy task. Okay, just holding on to that gasket has proved to be very challenging. So our engineering team has spent a lot of time developing a gripper that can grab onto that seal, hold it tightly, stick it down the bore of the pipe, locate the groove, and then open it up inside there. And then one of the things we wanted to show you today, Bo has a custom sensor that he designed to be able to check that the seating of that gasket in the system. Why don't you go ahead and show him that, Bo? That's
Get the video on that.
Sure. So this board that he's made here, I'm gonna pass the mic down to him.
Okay, so let's get that up and running here. So let me reset this. Okay, so if you see the screen, basically it's representing this has 24 sensors all the way around, and it's sensing in real time. I don't know if you can see that. The red is a little bit difficult to see, but the red is indicating error as far as outside of roundness. And so what we would actually do is we would insert this down into the pipe, and if the ring is seated properly, then you would see a bump equally all the way around. You would see it go red and then back out to green when it hits that ring that's inserted. If the ring somehow is not inserted properly, what happens then is that you'll see kind of an obtuse, or a shape that's not exactly round. So we'll know that if the ring isn't seated properly, we can readdress it as far as trying to reseat it. If you put your hand up there, Amber, and then I'll normalize it while your hand is there. It senses in both directions. So when I normalize it, it basically is saying, okay, that's normal. Now, if you take your hand away, now you can see that it goes inward. Now, if I normalize it again and say, okay, that's normal. Now, if I put something towards it, it bulges out. So if you have a ring, basically you insert it in the pipe, you normalize it, and now as it's going down the pipe, if it sees that O-ring and it's where it's supposed to be, it'll go outward because it's sensing that ring. It'll go outward. They'll all go outward at once and then go back to green as you're progressing through. If it's lopsided like it is with my hand right there, you'll know that the ring is not seated properly. Does that make sense? So that's essentially what this sensor does.
What is it used for technology for sensing?
Oh, it's just infrared actually, but it's yeah, it's just an infrared. It sends out an infrared and then it looks for reflection back. But like I said, there's a normalization feature that says, okay, whatever they're sensing right now, it's normal. And then it's what's the word? It's dynamic in the sense that it's ratiometric as far as the sensing ability. So once you define normal, it's going down the pipe and it says, okay, these sidewalls, are all consistent until we reach something that's an anomaly. It can be a hole in the pipe, it can be a groove in the pipe, it can be a ring in the pipe. Any obstruction in the pipe we can identify by just going down, inserting this down into the pipe.
Thank you, Bo. Got a little off topic there, but I wanted to show you guys that sensor. That's something we've been working on for a while, and it's kind of a cool demo of one of our custom boards. Anyway, so we sat down with this customer and we identified that this problem that they were having inserting these gaskets into these pipes was a big problem for them. They were trying to hire, low-cost employees, $12 to $13 an hour folks, and they couldn't retain them. Everybody was quitting after a couple of weeks because their hand would get sore and they would just be fighting with this thing so much. So they couldn't keep an employee in this position. And so it seemed like a prime candidate for automation. So then the next thing that we did, since we had identified, the issue that they wanted to address, we moved on to brainstorming different ways to solve that problem for them. And we did a lot of research going out in the existing market, because the one thing that we never want to do is design a custom solution if there's already an off-the-shelf one. It's always more expensive to build a custom solution than it is to just purchase an off-the-shelf machine that already does what you need, right? So we put a good bit of effort into trying to see what was out there in the market to insert O-rings or gaskets inside a tube. And there is almost nothing. It's amazing. You would think that they would have that in the automation industry. There's two companies that had something. We contacted the first one and they said, we gave up on that long time ago. We never could get it to work right. Okay, so the other one had a working solution, but it could only go down to about a 2-inch depth before they started having trouble with it. Nobody had anything that would go in 3 and 4. On the larger pipes, we have 4 and 5-inch depths, insertion depths on those. So nobody had a solution. So then it was time to design a completely custom solution for this thing. And that, took us to the next phase of our process, where we sit down with our engineering team and we look through the problem and we just try to come up with ways to solve this. So we have several mechanical engineers on our staff, and we spent a few days, actually probably a few weeks. We tried about 6 different methods to put this thing down the bore, and they were all failing. This is challenging, let me tell you. So we finally settled on a mechanical clamping system and some custom shaped jaws that could hold on to that ring, because the ring is bigger than the diameter of the pipe. It has to seat out into a groove. So you can't just hold it and stick it down the bore. It has to be shrunk. It has to be compressed down. So we've come up with a system where you have 2 jaws that are hemispherical or semicircular, half of a circle, and a pair of pins that compresses the ring into slots in those jaws, and then they clamp down on those tails. Then the thing puts it down the bore and opens up inside there. And I'm sorry, I really wish I could share all this with you, but the details of the design are proprietary to this customer, and I'm not allowed to actually show any of it. Okay, that's another thing that's important for us, is protecting that customer's intellectual property. So I can talk a little bit about how this works, but I can't show pictures or videos of this thing. Anyway, you take that compressed O-ring, stick it down the bore, and then open it up inside there. Well, that leaves 2 little bumps, if you can envision this, where the jaws compressed it into the upper and lower parts of the groove, but not the sides. So now we have to address that. So we recompress the tool, rotate it 90 degrees, and then open it again to seat those other bumps. And then we come back in with this sensor and check the placement. So what am I supposed to be talking about here? Oh, sorry. Got off on a tangent again on the tech stuff. That's the part I like.
You gotta do that. How long does it take to put it in and do all of it?
Well, it's a fairly quick process. We're using some of the smart servo motors that are out there to be able to calibrate and maintain position throughout the whole thing. So it should be, again, we're still in the process of building this version of the thing. So the placement should take place in about 3 to 4 seconds. Yeah, it should be much faster than a human can do it.
This pipe is good. The pipe is being manufactured coming off an extruder, and then they bail the end. They bail the end, and then they cut these grooves in there. So it's a continuous process. So we have to take it, receive the pipe, do all the different various things we're doing to it, including putting the ring inside, and then have the pipe exit our part of the machine, and not slow this thing down anyway. So we have a certain amount of time for every station to perform our operation on it. So.
Right, it's coming off an extruder that runs continuously, and if it has to be shut down for any reason, it takes hours to recover and start back up.
Well, that sort of leads into our next point of design. Wait,
Okay,
well,
design was what, we just through that. Anyway, so once we've come up with an idea, then it's time for the engineering team to start designing all the parts. And it's not enough to just come up with the concept. We have to actually turn this into working, moving mechanical parts. And there's a lot of things to take into consideration when you're designing mechanical parts. You guys, some of you may do some dabbling with some 3D printing or machining, anything. Anybody do machining? No? 3D printing? A little bit? Okay. So there's a lot of design considerations for these different processes. If you're turning a part on a lathe versus putting it in a milling machine or 3D printing it. You can draw geometries in CAD program that can't actually be made. Yeah, you can. It's just, you have to put a lot of thought into where the features can go, and then into how much cost in material and production time has to go into that, right? Every feature that has to be machined on a part costs money. So if you're making one or two of a part, it's not a big deal. But if you're going to make hundreds of them, it gets really expensive really quick. So when from a design standpoint, you just have to put a lot of thought and effort into making the parts simple and finding off-the-shelf parts where you can to use in a product, right? If you design every part in that as a custom part, it takes a lot more effort to build the thing than if you just make, use a lot of off-the-shelf parts where you can. So once all the parts are made, you put it together and build it and then start testing it. And a lot of that goes over to Bo for programming, right? Because now we've made the part and it theoretically should do what it's supposed to do, but somebody's still got to program all the motion sequences on it. Right. So you want to elaborate on that a little bit?
Well,
What languages you use and
typically the approach that I use, I consider myself kind of old school. I prefer my programming language. I prefer assembly language, but there's other programs that I use. But the process, what I initially do is I try to figure out, what needs to be done. And again, old school, I like to do a flow chart. I think flow charts are worth their weight in gold because as far as keeping things straight, you can do a one-to-one correspondence between the flow chart and the program itself. If you have to go back to the program a week, a month, a year later, it's a lot easier to get your head back into it and make a change if you need to, or you just switch gears basically. I mean, we've got so many different programs going, in my line of work throughout a daily basis that, I've got to be able to switch from one project to the next and be able to get my head into every single one of them within a timely fashion. And so, flow charting is really, for complex designs, is really the only way to go as far as I'm concerned. And it just makes the structure of the program much easier to maintain. But no, as far as programming and designing circuit boards, that's kind of my wheelhouse as far as what I do. I've had a hobby in electronics since I was 8. Taught myself assembly language when I was 12, and just kind of self-taught all along the way. So it kind of comes natural as far as that goes, as far as the process. But you learn a few things along the way. I mean, when I first started out programming, my structure was completely different. And you have through experience, you learn different techniques and different ways of doing it. So, and streamline it along the way.
another piece I forgot to mention in there is John's part of it. And then, some of these machines that we build are quite large and we have to have power distribution and data cabling and electrical panels laid out and all that. So tell them a little bit about what you do on that.
I think Bo and I, we tend to work on the tail end of these projects. So the machine's been defined, it's been designed mechanically. Well, it just sits there if you don't apply power to it of some kind, whether mechanical power, electrical power, whatever. And we always have to have feedback from sensors of various types. And so once as a machine is being designed, then I'll take that design and apply all the sensors. Well, then I have to wire all this, bring all the sensors into a control cabinet. We also have to have power. Sometimes we're dealing with 480 volt, 3-phase power, and OSHA requires us to keep all that kind of stuff. Anything that's over 50 volts has to be kept in a separate enclosure away from non-qualified personnel. And so I have to separate those two out and then have interconnects between the two. And then how's the cabling going to operate with this machine? This machine's moving. So we have to use cable chains that you probably have seen these things before, but it's just a chain. It's a flexible wire duct. So as the machine's moving, the wires are moving with it. And so we have to take all that into account. Well, then all the different sizes of wires. You got instrumentation cables that are twisted pair, or they may be shielded. They have power that has a certain size. So we have to figure out, okay, here's all the cables that are going from point A to point B. What's the cross-sectional area of those cables? And then how much space is it going to require in this cable chain? And how long does it have to be? How much does it have to move? There's a lot of design that goes into all that stuff. And then I'll work with that. Well, then my cable chain becomes in the way of some mechanical things. So I have to coordinate all that with the mechanical motion of these machines. Then we have to tell it how to control this thing. And so, you know, if you can't control something you don't understand, so I'm the controls type guy, but I tend to want to have to understand the mechanical side of it too. So I accuse Nathan often of trying to turn me into a mechanical engineer. So anyway, so I get very involved in that, even in the early meetings with the customers and trying to understand the concepts, because, you know, it might sound like a good plan, but if I can't control it, then it's probably not going to work. Then I'll lay out, once I get everything identified, I'll lay out all the terminals, lay out the cabinets and using wiring ducts and just all these years of experience of laying these things out, because somebody's gonna have to wire it up. Well, again, like Nathan said, you know, you can design things you can't build. So I don't want to design a control cabinet that somebody can't build and somebody can't maintain. And all through that process, I'm trying to be very diligent and documenting it all. I use a lot of 2D CAD to lay out the schematics, wiring diagrams, process flow diagrams, all those type of things, so that at the end of the project, I can just print them out and hand them to the customer, and there's our document package for how this thing is wired up. I think probably all of you guys have been frustrated over the years of insufficient documentation, you know, or you get a document and you look at what the product is, you know, like, this can't be the same thing, you know. So they haven't updated it. So that's part of what I do. I've been both the creator and the victim of that type of insufficient design of this thing. Yeah. And getting some of these sensors and things, you wonder who in the world is at the manufacturer of this stuff is designing this. So they'll tell you all about how wonderful this thing, then they fail to tell you what the voltage range is for the sensor. Like, well, how am I going to hook it up? So, well, sometimes we have to experiment. We have to put it on the bench and try it and see if it'll work, and see if I let the smoke out, it's going to not work. So I don't want that wire to become the fuse, you know, that type of thing. So, you know, so
sometimes there's a language barrier too on the instructions or the data sheet. It's not.
oh yeah, there's a column of Chinese and there's what they interpret as the English for that. And you look at it and we have to pass it around like, what do you understand that to mean? So, you know, it's a challenge at times. So anyway, that's the part I do. And then you know, a lot of times I'll build the first issue of something that maybe we're going to build several of them and get it all laid out and tweak on the design. Then we hand it over to the technicians that will actually start producing, you know, for having build more than one of them. The other challenge is a lot of the things that we build or we design, it's never been built before. It's a one of a kind. It's maybe the only one ever been rebuilt. I don't know, maybe 6 months ago, we rebuilt an old CNC router table for a customer. It's a really large router table. It's like, you know, a 4x8 bed on it. 8 horsepower spindles on this thing. It had dual spindles, and it was a really, really old control system. And we just gutted the cabinet, took them all off, and so basically designed the electrical and the controls from scratch using a CNC controller from Australia. Is what we use. So we had to interpret all that and try to integrate the design into something that could be used. It actually worked.
Well, thank you, John. Okay. Once the machine is built and everything's tested and working, then we have the fun part of taking it to the customer site and installing it into their production line. In a situation like our pipe making customer, where they're running a continuous extrusion process, that means we have to shut down their line. We're going to impact their operations. And so we try to make sure that everything goes together as smoothly and cleanly as possible. And we still have to, you know, wire it into their existing machinery and level it to their floor and do all kinds of handoff testing between our machine and their machine. And it just, there's so much that goes into that. You know, it's just, you think about just getting a new piece of equipment and you just bring it home and you plug it in and you use it. But even in your ham shack, I mean, you guys know what happens if you get a new antenna tuner or something like that. You have to rewire everything, right? I mean, it's not just a simple plug it in and go. And it's 10 times worse when we're talking about a machine that's 20 or 30 feet long and 10 feet wide and ties into upstream and downstream other machinery that has to hand off. So we have to go through a lot of planning on that installation process, coordinate with the customer, make sure that we can shut down their line and, be ready to handle any issues that come up if things don't go as smoothly as we hope, right? I mean, when have you ever installed something that worked perfectly the first time? So there's always that. There's a lot of on-site troubleshooting and testing and last minute adjustments that have to be made. And then of course we have to sit there and support the thing after the fact to make sure that it's running smoothly, there's nothing breaking down, and make sure that we train their staff on how to operate that machine, how to work safely around it. And then once we turn it over fully to them, we still have to provide support after the fact. So just designing and building a machine, it's got so much that goes with it from the discovery phase and just figuring out how to do something all the way through the support after the fact. It's a lot that goes into that. Anyway, in conclusion, I guess we would like to invite any of you guys out that ever want to come out and see kind of some of what we do. We've got an in-house machine shop. We've got an in-house welding and fabrication section of the building. We've got mechanical engineers and electrical engineers and lots of stuff that we do. I encourage our employees to do personal projects after hours and just tinker and learn. And I'm trying to get these two guys to step up and become ham operators. So, I still don't understand. Bo's been dabbling with electronics and tinkering his entire life and never become a ham operator. That one just boggles my mind.
Test every month in the very room you're sitting in.
It's actually kind of funny because when I was younger, these personal stories. When I was younger, I was one of those Atari guys. I had an Atari computer and I listened to shortwave radio all the time. And so through after realizing that I could program the Atari, just the game system, and I could use the output ports as input ports as well. I had something that I tuned into the radio that would actually decode Morse code and print it in text where I could read it. And I had it go in reverse the opposite direction. To where if I type something in, it would actually generate the Morse code. Mind you, I was probably 14 years old or less. So, fiddling with that and doing that sort of stuff back then, it is a wonder why I don't have a ham license. And I, like I said, I've broadcast accidentally several times. So probably.
They do the testing right here.
Right.
Said, when is it? When is the testing?
First Thursday of every month.
Right.
First Thursday of every month. Okay.
All right. Well.
Both
I've got a
cool
book I
kids
can
have ham license.
Yeah,
All right. I would like to open the floor to questions, I guess, at this point. Mark?
Okay, Nathan, I'll throw it at you. I've got a question. If you would, for us out here in the amateur radio world, tell us what you could do specifically for amateur radio, since you are ham, and what you could build based on what we normally do in amateur radio world.
Well, let's go through the process on that right now. What do you guys need that doesn't exist in the marketplace? Yes, sir.
I'd like to have a robot that could climb a radio tower and install an antenna.
Okay, a robot that can climb a radio tower and install an antenna.
Yes.
What you need?
What else do we need?
APRS.
Yes, sir.
I'm curious that when you design a system for your project,
Uh-huh.
are you manufacturing your own circuit boards? Are you buying off the shelf components from SMA or through whole technology or IC circuitry, IC chip circuitry? Do you have local resources for those things?
Well, we do design a lot of circuit boards. We don't manufacture the boards in-house. In fact, to my knowledge, there's only 2 or 3 companies in the US that have the capability of actually making the board part of the circuit board here in this country. Pretty much all of that takes place in China. We do send our designs over there for them to make the boards. If we're just doing a test run, then we don't have them populate the boards. We just have them send us the raw boards and we populate them by hand. Any kind of a production volume, 20 pieces and up, probably we have them populate them as well. It's amazingly affordable and quick. And we do have to tell them where to source the components from. And to that end, you upload a bill of materials file. Bo could tell you more about that, but you upload a bill of materials file and specify the manufacturers of the components that you want to use. Here when we're populating by hand here in the US, we mostly get parts from DigiKey and Mouser and things like that. I'm aware that there are a few local companies that delve into some of this stuff, but I'm not very familiar with them. You have some resources you'd like to suggest? No, there's very little local. In fact, it's been surprising, and kind of like Mark found Oklahoma Robotics. I think we're one of only a very few number of robotics companies here that actually design and create things from scratch. Most companies that call themselves robotics companies are what we would call a product integrator. They'll take an off-the-shelf robotic arm from Fanuc or one of the other big manufacturers and integrate that into someone's production process, but they don't design and build the thing themselves. So,
do you do a lot of 3D printing of the parts and accessories you need to make your kits work?
We 3D print stuff almost every day. We have multiple 3D printers that are running almost continuously because all the parts that we design, we want to print, test fit everything with 3D printed parts before we actually go to the cost and part of machining them. Machining is just so much more expensive, even with an in-house machining operation, than 3D printing. It's amazingly easy to just, hit a button and you run through a slicer and hit a button and wait a few hours and the part comes out almost ready to use with very little final cleanup on it. It's just an amazing process. But yes, we do a lot of 3D printing.
Question from the peanut gallery.
Go ahead, Lee.
Yes, I build magnetic loop antennas, and part of the magnetic loop antenna is using a variable air capacitor or a vacuum capacitor. And the larger ones, are producing a lot more voltage or a lot more wattage. And so I'm looking at using a stepper motor to do finite control. And the biggest thing I'm looking for is, affordable in that you can use also an IR or some type of transmitter so you can separate yourself from the antenna to adjust it.
Okay, so does your process require any kind of a feedback loop to tune the capacitor, or is it something you just want to be able to turn a dial down at your ground station and it adjusts it somewhere else?
Yeah, you have to tune the station for the highest reception capability, highest S units that you can get.
Okay, so if it's a man in the middle kind of control loop, that's actually very easy to do. We've got some boards that we've designed that would allow, a potentiometer input to control a stepper motor's position. And stepper motors are very low cost. So what you would need would be the control board with a little bit of custom programming on it, and then some kind of a stepper motor driver and a stepper motor.
And you can make that wireless too, to separate yourself.
Absolutely. Yeah. We've got a wireless link module that Bo's been working with that's on 2.4 gigahertz that can transmit data wirelessly very easily, very, very low cost.
As long as that's not going to interfere with what you're actually using the antenna for.
Fully encrypted as well. Yeah. How much?
Okay,
Yeah.
and also, have you heard of a company called OSH Park?
Osh Park. Yeah, absolutely.
They do boards.
Osh Park does boards.
Yes.
Yes, they do. They also have a service called Osh Cut, I believe, is a spinoff out of their company that we use for laser cutting metal from time to time. It's one of the processes we don't have in-house.
Well, I've used them for a couple of boards that I have in the antennas. That's the reason I was wondering.
Yeah, absolutely. We've used Osh Park a couple times. I'm not sure why we've moved away from them so much. I think it's largely just due to cost. They're quite a bit more
we can get
costly.
some cheaper solutions right out of China, I think. for some
Yeah,
things that we're doing.
unfortunately, and we may need to look at bringing that back because we've been having some issues with that too. So, yeah, if you're yes,
Well, I had a question about maybe realities and stuff. When you design this equipment, one of a kind, who owns the rights to that? Do you own the right to it?
The customer.
Buys it, own the right?
Yeah, the customer owns the rights to that because we are essentially acting as an outsourced R&D facility for that project. They're paying us for our engineering time and they own the rights to the work.
Okay. I would imagine something like that sensor may be patentable.
It may be, and it would be up to them if they want to patent it. We're showing it to you today. Quite honestly, we probably shouldn't be, but you know, they've not expressed any interest in keeping it a secret or patenting
The
it. But
sensor itself, basically, we derived from an existing product that's linear. We derived this sensor from an existing product that's linear. We just basically took that and wrapped it in a circle. But as far as anything, a wow factor, as far as any of the electronics, it's pretty standard. I mean, it's an infrared transmitter receiver. Like I said, we've just wrapped it around in the circle. We're sending all those the values to a microprocessor, and it's sending it in a serial stream to the computer. I wrote a Visual Basic program that interprets that data so that you can see it. I mean, that there's really nothing outstanding with this. I mean, other than how we're using it. Yeah, how we're using it.
Well, I imagine that could be adapted to a lot of things like, somebody needs to check the uniformity of the interior of the pipe or something.
Right.
Like that.
Sure.
it's the form factor that's unique to it. The core technology there is not anything we developed. And that's why we're more able to share this. Unfortunately, most of the stuff that we do, we just can't show you and can only a little bit talk about it. One of our previous projects that I thought was really cool is we designed and built a 5-axis laser system for cutting dental. You guys know what an Invisalign tray is? Well, there's another company that competes with Invisalign. They're here in Oklahoma. And they make those trays by vacuum forming a piece of thin plastic over a 3D printed model of the patient's teeth. And they have a program that they've developed where they take the teeth, they scan the jaw, scan the mouth, and they take an image of the teeth the way they are now. And then the doctor sits in there and tweaks the model to make it look the way he wants it to look when you're done. And they 3D print a whole series of jaws in between there. And then they vacuum form over all those jaws. And then they have to cut the vacuum formed plastic tray off of the 3D printed model. And so they were doing that with 5-axis machining centers, which is very slow, very costly, and very, it creates a huge amount of plastic powder, plastic dust, right? That they then have to clean up. So we designed and built 2 5-axis laser systems for them that you put the model in the tray and it sucks it inside an enclosure and it sits there and it rotates this model in front of the laser and cuts it out and then spits it out again. So all they have to do is load it on the tray, hit the button, and it comes out all cut out for them. So, yes.
Okay, so both my daughters have expressed a lot of interest in STEM and robotics and all
Awesome.
that. So is there any resources that you know of that they could start looking at for going down that avenue?
Well, I could answer that.
Yeah, sure.
One program that we got involved with our kids, and I'm a pretty big fan of, is the First Robotics. I actually coached an all-girls league at one point, and this would be the first Lego league from First Robotics. I'm guessing, and there's also a younger Lego league as well. So they'll use the Lego platform for the building. Lego has sensors. It has a nice little WYSIWYG interface to learn programming. So you learn all the aspects of robotics, the programming, the mechanical, the software. And there was a big field, and so there were challenges. So there was also an element of game strategy because they designed the game to be impossible to get all the points in the amount of time that was allotted. And so you had to actually develop a strategy of, I'm going to go for the points here and here and here because I know we can build and develop. Oh, that's got a bunch of points here. It's harder. We may try it, but let's also make sure we're getting enough other points. There was a ton of strategy with that. Also, with what I loved about First Lego League in particular was there's also the presentation. So even if a child had more of the artistic bent, which I'm more of the art side of things. This actually incorporated then because, well, as today we're here presenting, we have artwork, graphics to help explain these concepts. So this program also judged you on your presentation. You had to explain a problem solution to judges. So, and then you showed, your team at a booth as if it was like a trade show. It was just, to me, it just hit all the boxes. So a really great program. I highly recommend it.
Right. If your school doesn't have it, or are they in school or homeschooled or?
They go to small school.
Okay, if your school doesn't have it, there's a group in town called the STEAM Engine. And I believe one of their core goals is to help find ways for kids that are interested to participate if their school doesn't have a program. We've attended a couple of their events and they seem to be really great folks, and you might reach out to them if the school doesn't have it, or you can always start your own group. There are a lot of homeschool groups that do this. They get enough people together to form a team, and you can compete at the local and regional and state levels all the way up to nationals if you can make it that far. But like Amber said, they put together a trade show booth. They put together a presentation for the judges on what their robot does and why you chose to go that direction with it. And then they have to actually build the robot out of Lego parts that are in the kit and program it to do a series of challenges. And it's a whole new field and challenge every year. It's a really cool program. So
if you would show us your two robotics that you brought this morning and explain a little about both of those. And
okay. Well, if Bo can get that powered up over there.
Real quick question.
Yes, sir.
What's the address of your location?
We are at 1528 Southeast 27th Street in Oklahoma City.
1528 South.
Yes, sir. Back there behind the McDonald's. So this platform here is a technology demonstrator. This was a customer had a project that they needed a platform that could self-level on uneven terrain. The intent was to make a very large scale version of this and set it underneath a cargo helicopter, drop it in the field. I think it's even maybe smaller than that. I think it's 1/16 scale or so. Anyway, just to do a proof of concept for the customer to use with some potential investors that they had, we built this small scale model. And again, the intent, it's kind of interesting to show, Bo, if you'll actually stick something under one of the legs, you'll see how it adjusts to uneven terrain. Well, it just takes a second. Stick it up on the laptop or something if you need to. Just enough to cause it to be off kilter and uneven.
Here's a good use to correct radio amateur book.
It's only standing on 3 legs, but yeah, there you go. It's too well balanced to do what it needs to do. But basically it just tries to return the platform to level all the time. There's an IMU sensor on the bottom that reads the current level state, and then the microcontroller sits there and filters the results. And the IMUs are very unstable and jittery, so there's a lot of filtering that has to go into the code on the micro to stabilize that. And so that's basically just a small concept.
So that keeps your beer level. Is that
Concept model. Yeah, it'll keep your beer level.
what kind of concept would that? What kind of concept would that prove? To me, it looks like a offshore drilling rig trying to.
Well, I mean,
Stabilize.
yeah, because I mean, this is basically designed to be dropped from a helicopter. So you'd have, chains going up to a point, and as it's dropped, it would actually land from,
It would be sat down under helicopter on uneven terrain, and then it would self-level and allow it to deploy what it was supposed to deploy, which I can't talk about.
Without killing you.
Yeah. So
I
anyway.
was about to say, I'm glad that-
Anyway, and then over here we have the Caddie Bot. Now this is not normally what we do. I brought this today because it's a really cool demo piece and people love to see robots driving around and stuff. The Caddie Bot is made by Robotics out of China, and this was a demo unit that they've got on loan to us. And these are designed to work in restaurants. With everything going on with COVID, the wait staff shortage and contamination issues, they came out with a whole line of robots that are designed to just bring your food out to the table. So it's essentially a non-contact system. The kitchen puts the food on the robot, tells it which table to go to. Yeah, there you go. Put the food on there. Now tell it where to go. Go ahead and touch the screen there. Okay, now pick a table. Say table 4.
Table 4. Okay.
Yeah, hit start.
Well, I didn't select it. Okay. Thank you.
And there she
Table
goes.
4,
So
whoever you are, is going to get a donut.
table 4 is getting a donut. That's when she brings the donut over and you take it away, you hit the done button and she goes back to the kitchen. It's just that simple. So this robot has a built-in LiDAR scanner down in the base. There you go. All right, you got him a donut. So this has a built-in LiDAR scanner, and this morning before most of y'all got here, what I did was I took it and I pushed it around the room and allowed it to create a map of all the tables and everything that was in the room. And then I assigned a variety of tables, different numbers. And now it's going to adapt. Mark's standing in the way.
It's yelling at me.
Mark's standing in the way, so it's trying to find a way around him to get back where it's supposed to go. And if it can't find a way, it'll say, I can't get through. Please move. So, yeah. Anyway. Yeah, I think I misprogrammed this as table number 7. But
Did you say it's LiDAR and the same technology, self-driving cars?
very, very similar, yes. This one only creates a 2D map of the level right around the floor, people's legs, tables legs, and stuff like that. So, the self-driving cars need more 3-dimensional data. This is a very low-cost, simplistic thing. But, China has us, they kick our tails on this stuff all the time, guys. What if you had to guess what something like that cost or would retail for, what would you think? So it's right around $12,000 to $13,000 to deploy one of those units. And it's just, the technology that's in it's got dual displays, like 5 cameras, the LiDAR system, the motors, the battery, lithium battery. there's so much stuff there for, their cost on it has to be less than half that to be able to actually sell it through a distributor at that price. And they're shipping these things by the tens of thousands.
They're actually using these
Oh, yeah.
in restaurants?
These are in fact, a lot of Asian restaurants are completely operated by things like this.
There's also the.
It's starting to catch on here in the US. They're all over Europe. They're all over Asia. California's hitting them pretty hard. McDonald's has signed with one of the companies for to deliver some 30,000 units or something like that in the next 6 months. So it's getting crazy. It's going to that.
So do you have to tip the robot?
No tipping needed. And
we've tried to mechanically tip it.
The cat likes to chase it.
Yeah, when we first got it, we tied like a Christmas string to it, and the cat went nuts. The cat just loved it, chased it all around the building and everything.
So if I do 2, will it go to both of them?
It will. It'll go to up to 3 in a sequence there.
Well, you didn't put a donut on it. Come on.
I think we're running out of donuts.
Tell it that you acknowledge that you acknowledge it come by.
I have to wait for somebody else. Good luck.
Yeah, sorry guys, I didn't program tables over here because there were cords all over the floor and I didn't want to try to get tangled up in those, but it's yeah, that's the thing. Like the front screen can be programmed with all kinds of advertising and menus and things of that nature. Yeah, I didn't have time this morning to set it up. I wanted to put the ARRL logo on there, but I didn't get it done. So and you guys' logo. So
There you go.
yeah. All right. Here's robot stickers here if you want some. That's it. That's pretty easy.
There you go.
And Mark, you were here this morning. How long would it take me to map the room?
Oh, not very, it didn't
Like
take very long.
5-10 minutes. I just wheeled it around.
in 5
Yeah.
minutes. Grab the sticker and hit done. Yeah, I didn't realize what he was doing. I thought he was lost and he couldn't find the front of the room. He kept driving around and he finally came back and went, oh yeah, I programmed the whole room.
Yeah.
But it's found each table and
It's
kind of neat.
I think if you don't hit done, then she'll time out.
yeah, she times out. There she's
Just
timed
like
out.
just like a
There you go.
waitress.
All right. Any other questions?
What's next? What do you got? What do you see a year from now? What do you see a year from now?
Oh man, I'll tell you what, we're in some difficult economic times. I don't know what I see a year from now.
Yeah, but that'd be great for automation.
It can be. We've got to return some of the manufacturing, even if it's automated, to this country, guys. It's a real problem right now. We have several crew members laid off because we can't get materials in the door to build the things that we need to build. Just getting steel is taking weeks. Sheet metal, square tubing is taking weeks. It should not take weeks to get steel. We had at one point steel factories here in this country. We've got to get them reopened. I mean,
Where do you buy your steel from?
there's several distributors around town that we use trying to find the best prices. I think usually Albright or Ray Albright or one of those has some of the better deals. We're a small volume shop because we don't manufacture a product. We make one-off stuff. So we always need some square tubing or some, square rod or round bar or whatever. It's always something different. Special metals, metal supermarkets, but it's, trying to get that stuff. And I'm not talking about weird stuff. I'm just talking about like 18 gauge sheet metal, just raw steel sheet metal. Sometimes 2 weeks lead time on that stuff. I just tried to get copper bar. I got it faster, fully machined and plated out of China to my spec than I could just get the raw stock here.
Yep.
It's just really sad. So I hate to say, I don't know where that's going. I would like to think that it's picking back up and we're going to get stuff going here again. But if China and Russia continue to, slow our supply chain and make things difficult for us, this could be a really tough time.
Yep, I can see that.
Yeah.
A great time to automate because of people, but you can't get the stuff to
I
do
can't
it.
get the stuff. Yeah, we're so far down the rabbit hole that, as we're clawing our way back to the surface, it's just, I can't do everything in house. I can't make the steel. I can't dig the iron ore out of the ground. I have to be able to buy something at some level to make the parts. I can machine the parts, but if I can't get the steel, I can't run my machine to make parts.
I had a friend that was looking for a new air conditioner this week.
Ugh.
He was quoted 42 weeks
Yeah.
on a Sears 16 machine.
Well, we were quoted, what was it, electrical panels? Originally, we wanted to get some electrical panels for a project, and it was 12 weeks, and then it was 24 weeks, and then it was 64 weeks. And the breakers, yeah, all this stuff that goes in it. So we're having to make our own electrical panels now.
Yeah.
We're having to buy the sheet metal, which takes 2 weeks to get, and then, punch it out and weld it up and powder coat it and do all that stuff to just make our own electrical panels because we can't buy them.
Yep.
It's terrible.
Well, I really appreciate your efforts and your time. Thank you
Thank
very
you.
much. These are really neat toys and tools.
Enjoyed being here. Thank you, guys.
Let's sit for a 5-minute break and come on back.
Hey, Mark, give him that cram book.
That's on the counter.
First Thursday every month.
You see him playing with it now. It's that was our level adjuster piece. But yeah. Always got to get an ad for a cram book in.
Okay, let's start finding our chairs and we're going to get back into morning program. Everybody start finding their chairs again, please.
Okay, folks, let's get started with our business part of the meeting. If everybody will take their chairs and have a seat. I think there's some donuts left back there. We want to be sure and take care of those. We thank Bill for bringing those. Okay, first thing I want to mention is we publish the minutes to every meeting on the website. If you want to view the minutes and see what was going on, you go to w5noi.org/minutes and you can view the minutes from there. Before we get started with our regularly scheduled, I have something that I want to discuss with the club. Something I feel that it's very important. So we've had a lot of issues with the equipment that we use at the VE test sessions. With it's creating a bottleneck and processing the paperwork. I wrote this down so I make sure I explain it to you correctly. And it's pretty embarrassing and doesn't look good on the club when you struggle to get people checked in. And when you tell somebody they passed their test and they have to sit there and wait for us to struggle to get the paperwork printed out. And the SCARS VE manager, Peter Laws, has been gracious enough to let us use his personal laptops for these proceedings, but it's not working out very efficiently. So what I want to propose to the club is that the club purchase their own laptop to be used specifically for club business and mostly for the VE testing. I've done some research and I know that we can get a really good, decent laptop, not a cheap piece of junk, for under $500. And that includes shipping and any applicable taxes and stuff. So what I want to do is, and I want to mention that Peter Laws has already volunteered. I've talked to him to keep up the maintenance on this laptop, keep it updated with the Windows updates and whatever, as well as the updates on the software that we use for the VE testing. So at this time, I want to entertain, if somebody want to make a motion that we allocate up to $500 for the purchase of a new laptop to be used for SCARS business, primarily for the VE testing program. We've got a motion. Do we have a second? We've got a second. I know, I'm fixing to go there. Okay, now I'll open this up for discussion.
As far as the equipment, we've got the laptop, but should we also look at maybe a printer as well, just to help update and improve the process, so we have new equipment for everything?
We can. The printer that we got has been working, although the problems that we are having we believe it's in the laptop, but we may end up having to get a printer as well, and our printer don't cost as much at that. So are you making an amendment to the motion?
I think that I would like to see an amendment to go ahead and buy a printer as well, so we can just have a complete package.
Okay, are you wanting to amend the amount that I have proposed? We can get a good printer less than $100. But some of the good laptops that I've looked at, one that I'm looking at right now is $399. But it's going to be upgradable for the future if we need to upgrade it. But it's going to it's not going to be, we don't want to get a cheap laptop, but we don't need a barn burner anyway. So, but we need
Question, Mr.
something that's
President.
going to be reliable. Galen's got a question? No. We already have the software. The VE software comes free to us from Laurel VEC. And they're always pushing out updates at least once a week and such. So somebody had a question on the Zoom.
Yes, Lee Green Leaf. I have a question as to whether the club would accept a gift of a printer.
I'm sorry, you're not coming through, Lee.
I said, will the club accept the gift of a printer?
Yeah, as long as it's a good printer, then yeah, we don't have.
It's a Hewlett Packard printer that I used for my business. I've closed my business down and it's just in storage. It's multiple sheet correlation printer. It's a business printer.
Okay, absolutely. Yeah, then we'll take a donation.
Does it fit in the cabinet?
Yes.
Storage cabinet?
Yes. It's an HP 9810.
Oh, awesome. Okay, well, there we go. And we've got an
What do we
alternative
have?
for a
What do we
printer.
have now? Because our printer now is 2018, I think. If Mark,
Well, it was 2018 when it was donated to us. We don't know how old it actually is.
no, and we don't know that for certain that it's the problem. I suspect Wayne is correct, and that if we get a new laptop, we'll be fine. But maybe not.
But we won't know. We'll get this laptop.
Yeah, let's do the laptop
I
first
plan
and
on-
defer on the printer.
I plan on when we get the laptop, I'm gonna come down here probably during an Elmer night, hook it up to the printer and make sure everything is working appropriately before we get to the next test session and have to struggle through it. That is
a
my
wireless.
plan. I'm
This
sorry,
is a
sir.
wireless printer as well.
That'd be perfect. Yeah. Okay. We'll keep that in mind, Lee. We appreciate that. Any other discussion on this topic? Okay, I'm going to call the vote. Please signal ayes by raising your hand. 500, yes. Okay, I can't see you guys on Zoom. So you guys
They
on
can raise
Zoom
their
just say,
hand.
I'm sorry?
Click on reactions and do raise hand.
Okay, I see. I can't see you, Lee. Okay, I do see you now. I see Lee. I see Peter. Glenn? Okay, good deal. Any opposed? Any opposed? Put your hand down, Mike. All right, the
That's
motion
not
is
how that
carried and
works.
we'll move forward with this. Thank you all very much. That's going to help
Yes.
us a lot.
Yes, thank you very much.
All right, we're going to move right into the finance report with the Goodwin man, Mr. Larry. Who's playing music?
Okay, this month, we had $302 come in on memberships. That would be at $25. That's 12 new members. Several of them are new members, and then 2 of them were a family membership. As you can see, we had $26 come in on coffee, and the field day expenses we paid so far was $145.29. And we've got some that's we'll be paying out this month. Total expenses were, or net income was $138.93. Bottom line, we have $386 or $3,867 in the savings account, and of course $22,000 in savings. No, checking first. 3,800 in checking and 22,000 in savings. Anyone have any questions? Okay.
Awesome. Thank you, Larry. We appreciate everything that Larry's been doing. He's been keeping a tight grip on the money. And it looks like we're still doing in good shape. Scars is doing good. So, Mr. Mark Clayton, let me see what you got to say.
Field day was a good success. Really was. We had a lot of fun with it. We had good food, and we appreciate all the team that did that. Each station did pretty good. Of course, CW was tops in it, but everybody did good in it. We learned a lot from this field day as far as putting up gear, putting up antennas, and how to fix interference and problems that we had with this field day. We've got a solution that we're going to try for winter field day and again next year for summer. But it did come out really good. Appreciate everybody that helped and everybody that participated. We want to thank also Galen for the use of the Moore emergency truck. That was a real plus. And also for the use of this facility too, that we're able to use, which is really good for field day. And we appreciate that. We want to thank again the robotics team that came in today and did a wonderful program. And next month's program is a subject that a lot of folks have been asking questions on, and it's in reference to Whisper. So we're going to do a detailed program next month on Whisper and kind of there's a lot of pluses and a lot of different uses for that. So we'll have a good program for next month on that. That's about what I got, Wayne.
Okay, appreciate that. Scars has got a lot of good events coming down the pike. We were talking the other night at the executive meeting. We've got the Moore Norman night, the Moore National Night Out coming up in August. That's going to be a good deal. And of course, Norman has a national night out as well in the future. And then we do this gig at the Westheimer Airport. We're planning on doing it again this year. More details on all that will be coming up probably in the next month's meeting. All right, Mr. Mark Klein.
Don't spoil my thunder.
Turn the camera.
National Night Out is a event.
Turn the camera. Turn the camera.
Oh, you're fine. You don't need to see my ugly mug, Peter. National Night Out is an event that the law enforcement community uses to work with the various community folks. And more, we do a little different than what Norman has done. We have a single night event in a parking lot. It'll be at the Warren Theater. In that huge parking lot there's at least 60 various community organizations. Police will be there, fire will be there. We'll have the big truck there. But Scars, we missed last year, but we'd like to set up some working stations and and show off ham radio and do a little recruiting and talk to the public. So I don't know, what do we need to do in terms of figuring out who's going to be there? Klein, any ideas? I'm sorry, it's August 2nd. It's on a Tuesday night, runs 7 to 9. Yes, it'll be hot.
Yes, it'll be hot and we'll have plenty of heaters to make sure that works.
Lots of free food. Everything there is free, by the way.
We will post it on the Facebook page.
We'll do some announcement stuff. My theory currently is that we might shut down Elmer night since it's Tuesday night and route everybody up that direction is probably the right answer on that one. Because the faithful that are here Tuesday nights are usually the ones that do those national night out in the Westheimer group. And yeah, I'm looking at you guys. But we'll probably shut this down and run up that direction. Dang it, August 2nd is coming so much quicker than I thought it would be. So we'll have to put some stuff out. I'm going to guess we'll do like we've done in the past. We do demonstrations of sideband video, WinLink, Arden, all of that kind of good stuff. And Galen's promised us a 12 by 18 tent that's fully air conditioned. No, it won't be. Yes, sir, Mr.
Night out. When is the Norman night out?
It's generally later in the year.
Later in the year.
Norman's is usually in October. Into October. It's usually after the Westheimer event, and that's.
Yes, it is in October.
Okay, it is October. It's
Thank you,
usually
Lee.
early October on the other one. So August 2nd is the one in Moore. The good news is last year we did Norman and we did the airport. Both of those were very good events for us. All of our kind of people were there, and it was good to see folks and let them work with it. We brought a lot of folks that had a radio background and they hadn't used the radio in a long time that have gotten involved. So if you're wanting to help present, show on up and present. We'll be in More America. And like I said, we'll shut down Elmer Night here. More details in the newsletter coming up in a couple weeks.
And just want to come and see what's going on. There'll be at least 4 of the news and law enforcement helicopters around. So there'll be lots of cool stuff there.
Yeah, we're talking
cool
thousands of people, 10,000 people. So those of us that are really familiar with crowds like Ed, would be a good night for him to show up. No, those are usually great events, and we get a lot of people. We give away coloring stuff for the kids. We got a whole bunch of stuff we've done in the past, but those would be fun events. But yeah, like you said, Normans are Moores, Normans, OUs, and they also have a weather center is going to do a weather festival out in person this year. What is that? October 29th?
Something.
October 29th is what's going. I've contacted the Ross Forsyth from the museum to see if they're going to bring their big trailer out there again, and we usually house with them or Galen or David in one of those pieces. So lots of, or all of the above. Yeah, we can do all 3 stations. We got lots of cool stuff to do in the heat is probably the right answer. And a segue to that is July 22nd and 23rd is something called Ham Holiday. Who here has been to Ham Holiday in the past? Yay, make some noise. Ham Holiday is a ham fest in Oklahoma City. We usually have about 600-700 folks that show up. It's at Oklahoma City Community College. Last time we did this, we did it at Oklahoma City Community College up there at 7777 South May, maybe close to you guys. You might have heard of that place. July 22nd, 23rd, 22 and 23. 22nd, 23rd. 22nd, 23rd. So the event is coming up very shortly. I think it's 2 weeks from now. Scares those of us that are pushing the thing together. Tickets are available here. I have tickets, $10 tickets to get you in the door. You get a pre-registration ticket, and you get a registration ticket that allows you for 2 different prizes that we have, raffle prizes. It seems to be raffle year. The main raffle prize is an FTDX radio, probably a $1,300 radio, HF 6-meter radio. The pre-registration prize is an Anytone 868 DMR VHF UHF radio. good radio as well. And this time we have a special raffle that is a $2,100. Where's my special $2,100 package for the ICOM 705. It's about a $1,400 radio. And Ed and Dwayne are our two 705 aficionados. And they put together a really good package of an antenna tuner and some cages that go with it and some connectors and a little cool device that lets you do a remote display. It's a Bluetooth display that connects to the radio piece. So it's about a $2,100 package. And one $20 ticket gets you entry to that raffle. We are only doing 200 tickets. It's a limited $20 raffle ticket. So $20 gets you $2,100. These tickets are not available here, but you can do them online. I don't have any today. These you can go online and click at hamholiday.com. So right there is where you can purchase your tickets online. But I have, if you want to just hand over $10 and get an entry tickets, we can do that for the event. What's a Ham Fest? Ham Fest is where you bring 600-700 people together and you have sessions or forums where they teach everything. This year, we're going to do a bunch of new things for us. The big one that we're going to do is I think we call it ham skills on there. It's a one-on-one Elmering session. So we'll have a room all day long with people staffed in there. So if you have a question with your radio, you bring it in, you get it reprogrammed. We'll have soldering irons to show you how to solder. They'll have different kit kind of things on that piece. So that's one of the online forums. The rest of them are going to be things like Parks on the Air. Dwayne's going to do a Parks on the Air piece. We're going to do a WinLink section from Jeff Scoville out of Tulsa. That's going to do that. Those are all educational pieces. And then throughout the day, there's going to be about 140 tables of flea market stuff. So if you have gear that you want to sell, or if he has gear you want to sell, we get better deals when that happens, don't we, folks? But if you want to sell stuff, buy stuff, it's a really great place to be. There'll be vendors there to buy coax, buy radio gear, buy antennas, and all that kind of stuff. So if you've not been there before, plan to come July 22nd, 23rd. I have tickets here, or get them online, hamholiday.com.
Sorry, Mark. Did you already mention the tables?
Tables are available. Oh, no, I haven't talked about your part of the deal.
Oh, I was just going to say that Scars, the club, has already purchased 3 tables. You have something you want to sell, come stick it on our table and then see what you can get for it. You are responsible for it. If you walk away from it and somebody sells a piece of equipment for $5, I'm sorry. But anyway, Scars is sponsoring 3 tables at Ham Holiday. Anything else, Mr. Klein?
I'm sure there's thousands of things, but the big one is that one. Elmer Night's always Tuesday night. We come here, this building, Tuesday night, 6:30 to 9. Bring your problems, your questions, your concerns, and we'll help you walk through them. It's still been real popular. We probably had 1 to 2 new people every week that are either brand new to the hobby or like the folks that were stale for 10 years and they're coming back in, and it's a great place to get your hands on and ask questions. I've got a test book available. I gave one to Bo so he can get licensed up, but if you need some help getting a license, you're good to go.
All right. Thank you, Mr. Klein. We're going to go over here to Mr. Ed for the tech report.
I have no problem. What, Ed or the tech report? The everything up and running again. I actually had hopes that the dog barking had gone down, and then I think on the 10-meter net, somebody made me realize it's just because my chief reporter is out of state. So maybe not. Well, maybe we haven't any progress. Other than that, any questions?
No.
Back to you.
Good report. Awesome. Okay. I'm going to go around the room here and let's hear about the different nets we got going on. Mr. Bill with the 10-meter net.
Well, join us on Wednesday nights at 8 p.m. for the 10-meter net on 28.445 upper sideband. It doesn't take a huge antenna system to get on 10. So join us.
We appreciate you, Bill. And while I'm walking around to the other side of the room, Mr. Lee, talk about the DMR net, please. Mr. Lee Greenleaf.
All righty. DMR Net meets every Monday night at 8:15 p.m. on Talk Group 3140. We always try to do an educational session at that time. Very, very different things just about every week. We're getting somewhere up to close to 40 people now. People from a lot of states are also coming and joining us. So if you're interested in Aries or interested in DMR, Talk Group 3140, 8:15 p.m. on Monday evenings. Thank you, sir.
All right, thank you, Lee. I just want to give a plug for the 6 meter net. 6 meter net Monday nights at 8 p.m. on 50.200. If you've got 6 meter capability, join in. It's a lot of fun. And occasionally even propagation opens up and you'll be surprised who all checks in. Thank you with that. So I'm going to give it to Mr. Phil here. He's going to talk about the Aries Net.
Okay, the Aries Net happens Tuesday night at 8 p.m. local time, ordinarily on the STARS repeater. Every once in a while, we will run the net on the UHF repeater just for a check. It is a preparedness and training drill for Aries Net procedures. So it's kind of important for you to check in. Gives you an opportunity to shake down your equipment. The net control operator has been doing a great job holding that net. If the net control operators have a problem during their session, please give me a call and I'll cover for you. I think that's about it.
All right. Thank you, Mr. Phil. I'm going to go over here to Denny. Denny's going to talk about the MacNet and the Gossip Net.
Oh, my goodness. The MacNet is daily, Monday through Saturday at 9 o'clock. It's hosted by either Mike or myself, or once in a while we'll have a guest intruder in there. Anyhow, Monday through Friday, 9 o'clock in the morning. For everybody that's just getting up, if you're a little bit bashful on the microphone, as I say, go ahead and pick it up and let us know you're there. Because I know there's a bunch of listeners. Anyhow, thank you. For the Gossip Net, it's on Tuesday following the Aries Net, and where you can just pick up and talk about anything you like. And as they say, don't time out the repeater. But then you can go ahead and do it because Victor's got too many of them rewards to pass out. Anyhow, show up, see us on Tuesday or during the week in the mornings. Thank you, sir. You want to say something?
All right. Thank you, Danny. We appreciate your dedication to those nets. Mr. Peter Laws, talk about the Siren Net, please.
We have a Siren Net.
We do.
Oh, was that, you wanted more? So every Saturday at noon, weather permitting and football permitting in Norman, we run a little net after the sirens wind down. All the local cities and jurisdictions that have outdoor warning sirens test them all at noon on Saturdays these days. And we run a net in Norman, Moore, Noble, and Newcastle. And we report on your chosen siren, usually the one nearest your house. But if you care to go out and find one in the wilderness, Norman has 68 sirens. And there are some that just nobody lives near. Well, I mean, some people live near, but they don't have hams living near. And you report on whether or not they sounded. Sounding is good, not sounding is bad, but that's really important information for the city to allow them to target their repair efforts. Yes, the sirens are quite modern and have telemetry back to that little room over on the side there. But it's, as we've found over the years, it's not 100% accurate. And there are, it works both ways. The system will say, no, that siren didn't sound. And our reporters say, well, yeah, it did. And also the other other way around. The system will say no, that it went off, but our reporter sitting at the pole says, yeah, no, not really. So it's been good for the cities. It's a good activity. The net doesn't take long. It takes about 15, 20 minutes, a little longer when Wayne does it, but no, it doesn't take very long. We just it's a roll call net. We call your name, you tell us whether or not your siren sounded, and that's it. We record it and move on. Thanks to Mark, we've got it pretty well automated on the net controller side, where we have a database that gets updated and we can generate reports for the cities and stuff. So it's pretty cool. You have a siren. If you live in one of those cities and you live near a siren, let us know.
And I believe Mr. Ed Hatch is in the saddle today.
He is. He's just joined our rotation.
Just breaking him in, so be gentle.
We are, yeah, be gentle with him, yeah.
Well, thank you for that, Peter. While you're there, Peter, talk about the VE report.
Yeah, put that up on the screen, would you? On the big screen here on the thingy. It's not coming through as the picture on the. Yeah, like that. That's what I meant. Yeah. So test session the other night. 4 people passed stuff. Dino, we already mentioned. He give him another round of applause. He got amateur extra, which is pretty cool. Luke came up from I think he was from Lawton, passed his general, and Gary, who's from what was he from? Tuttle, he got to general, and then Steve was payment confirmed. What the hell is that? Well, they started collecting a fee for licenses. The FCC did. And once you pass, it used to be you pass, you usually got your license, your call sign, the very, right away. Now you got to get a file number, you pay through the thing online, and eventually it updates. Well, Steve was in payment confirmed status until I went to bed last night. Now go ahead and reload that screen. Hope this works. His call sign actually came through overnight, which is different than the past. Usually they didn't process that late at night, but here he's got his call sign. So Steve, if he's there, he's KFI WHA. To me, it's annoying. The system works pretty well, but it delays you getting your first license. So, and again, for those of you who've been asleep at the last few meetings, new license, $35, renewed license, $35, upgrade, free, change of address, free. Vanity call sign is also $35. So yeah, good session the other night. We'll have another one on August 4th, another one on September 1st. And of course, Ham Holiday. Have a session there.
All right, good deal. Well, while you're there, Peter, talk about Amazon Smile.
Oh, I actually pulled that up here somewhere. Yeah, so we got another disbursement. They didn't tell me about it until July 1. But back in May, we got a check for $104.14 from the Amazon Smile program. That brings our Smile total, since we started doing that part of Amazon's thing, to $1,800. We started doing that back in 2015. We started the Amazon affiliate stuff back in 2009, and we made another $500 from that. So our grand total is $2,391.48. So what is Smile? Well, you probably buy stuff at Amazon anyway. If you go to smile.amazon.com, it's exactly the same as Amazon, except the first time you go there, it'll say, hey, well, which 501c3 charity did you want to support? And of course, we would like it if you would pick the South Canadian Amateur Radio Society, Inc., a 501c3 organization. If you have another one that you'd prefer to do, that's fine. But if you don't, please consider clicking on South Canadian Amateur Radio Society there, and then we get 0.5% of whatever you spend at Amazon. Doesn't change the price you pay, comes out of Jeff Bezos' pocket, means he can't buy as much rocket fuel, I realize, but it's been lucrative. I gave you the numbers there, $1,883 in the last 7 years. So that's not nothing. That's really not usually over $100 a quarter is what we've been getting these days. Sometimes a little less, sometimes a little more. As you might imagine, the first disbursement after the Christmas season is usually our biggest one. But
All right, we appreciate that. We're all about getting free money.
yes.
All right, and I want to thank Peter for his hard work on that as well. I want to thank our guests for coming today. We appreciate it. It was a very good program.
Yes, it was.
I think we lost one, but that's okay. And next meeting is on August 13th. Anybody else have anything else to discuss? Dino.
One of our members, Bill, 85 as an upcoming trip to Alaska.
Oh, Phil's going to Alaska. Do you want to say a word about it? Nope. July 17th, he's going to Alaska.
If they have an HF station where I'm going, I'll call back in.
He says if they have an HF station where he's going to try to get out.
Maybe somebody will have a APRS.
Perhaps we can make, perhaps you can get on the Facebook page and make a sked. Awesome. That's pretty awesome. Anybody else? No? Well, let's call this meeting adjourned. Thank you for coming.